So hi everyone again. This is Abhishek Jain, founder and director of Achilles Racing Club. So with some collaborations, we are bringing these sessions to you to discuss about the vehicle dynamics, right, or the dynamics of a race car. So today in this session, we are going to discuss about the forces and movements that are acting on a vehicle, right. This session is very much important, very much crucial to understand about the suspension behavior, the transmission behavior or steering behavior of the vehicle. Let me just tell you one thing. With this session, you will get the utmost clarity about the things, the behavior of the vehicle to different forces or the movements that are acting on the vehicle. Right? Like most of the students have got the doubts. Why do we have got these virtual geometries like caster, camber or kingpin inclination? With this video, you will get to know about this thing. So it will help you a lot if you are working in the steering department. As well as for the suspension department people, it will help them to understand about the behavior of the vehicle while dealing with these forces. Right? Okay. So I guess we have to start with the session now. So I just told you, today's session is all about the forces and movements that are acting on the vehicle. Right? The forces that are acting on the vehicle and how these forces are converted into movement. What kind of movements are these forces going to produce in our vehicle? Right? Okay, let us just revise this thing first. If this is my vehicle, let's talk about the axis and the planes of the vehicle. If this is my vehicle, right, this is the front part. Front. My vehicle is running in this direction, right? Okay, now this is the rear part. And this is what I can say, my right side or left side. Sorry, this is the right now. Okay, right side and left. So the axis joining the front and the rear compartment, the endless length, the infinite length axis, joining the front and the rear part is known as longitudinal axis. The axis joining the right and left is known as lateral axis. And the axis going up to down, if this is my vehicle, alright, so this blue marker is my vehicle, right? The front part, the rear part, the right or the left, the sideways, front, rear, right, left, whatever. Axis going through it, axis passing through this front to rear end is known as longitudinal axis. Axis passing across me, through me and you, this direction, is known as lateral axis. And now here I have got the tires downward, here I have got my driver seated. Up to down. This axis is known as transverse axis. I am denoting it with a dot, right? With a dot. Transverse axis, right? The movement along the longitudinal axis, when my vehicle is moving, because of the surface irregularities, you will always notice there are certain movement. This movement is known as rolling, right? Movement of the vehicle in this manner. Lateral axis. The movement along the lateral axis is known as pitching. Right? So whenever I apply, this is my vehicle. Again, the blue marker is my vehicle. This is my lateral axis. So whenever I apply the brake or whenever I accelerate the vehicle, I can see my weight is shifting towards the front part or towards the rear part respectively. So this is known as pitching. And see, this is my vehicle, this is the transverse axis. This is my vehicle, front, rear, right, left. And this is the transverse axis, up to down. The movement along the transverse axis. This is my transverse, the movement along the transverse axis. See, the motion of the blue marker, the movement along the transverse axis. The steering input, that is known as yaw. Okay. Now we have already talked about this axis system, longitudinal, lateral, transverse. Now let's go with the 3D planar system. So if this is my vehicle, see this hand, this palm is my vehicle, right? This palm heading towards you. Rear end, front part, left or right, right? Okay. Now see, the longitudinal axis, and the plane along the longitudinal, the top plane, right? This is known as top plane, right? This is my longitudinal axis, this is my top plane. This is my lateral axis, the plane perpendicular to it, see, like this, lateral plane, right? Now this is my transverse axis, Now along the transverse axis, see this right plane, a plane is going like this, a plane is passing like this, perpendicular again, right? Now this top plane, we can call this top plane as the longitudinal plane. This is my lateral axis, this is known as lateral plane, or you could say the front plane, right? Front plane, you can call it the front plane, and this sideways plane along the transverse axis, this is side plane, or you can call it the transverse plane. Now there are three views. Okay, let's move very fast. There are three views. Front view. When I see my vehicle from front, the horizontal line across the front plane, this is the lateral axis. The horizontal line, this is the front plane. Facing towards you is the front plane. Okay. This horizontal line across the front plane is known as lateral axis, or this front plane is known as lateral plane. Okay. This line heading towards you, like this, towards you, pointing towards you. See, this is lateral, pointing towards you. This is the longitudinal, a plane above it, top plane. Yes, this is known as longitudinal plane. Right? Now this plane, this axis, a plane crossing like this, is known as side plane, though it's the side view geometry. From the side view, you can see a perpendicular part, right? This part. From the side view, if I see, this is known as the transverse plane. Right? This is known as the transverse plane. You got this thing? Okay. Now let's talk about the motion of the vehicle. If I say in particular what are the total forces that are acting on the vehicle, I would say there are only three forces that are acting on the vehicle, or there are only three directions of the forces. Particularly when I talk about three forces, it means three directions of the forces. I could say the longitudinal force, transverse force, or the lateral force. The longitudinal force, with the black mark I will write because there is a proper ink inside. Longitudinal force, any force that acts in the direction of longitudinal axis. Any force that acts in the direction of longitudinal axis is known as longitudinal force. Or I could say lateral force. Any force that acts in the direction of lateral axis is known as lateral force. And I will say the transverse force. Any force that acts in the direction of transverse axis is known as transverse force. Now see, what are those longitudinal forces? When you apply the brake, see, longitudinal forces in this direction, right? Reaction of the tire when it moves, or when you apply the brake, the inertial forces that are moving forward, that are making you move forward, when you accelerate, that makes you to move backward, right? Though it's not pushing you, it stays in the same line, the vehicle moves forward. The air and bird force, right? Okay. Now, which force? We can call it the tractive force. Again, in the tractive, it could be braking, or it could be accelerating, right? Acceleration or deceleration. Okay. Now lateral force. When I take a corner, this inertial force that pushes me in this direction, in the opposite direction, or the centripetal forces that are acting, right? When the tire is sticking, the slipping forces that are happening, the interim property of the tire, the change in the shape of the tire causes this slipping force, right? So I can call it the cornering force, which I can say the centripetal or the centrifugal force, whatever you want to name it, centripetal force, as well as the slipping force. Interim property of tire property. Transverse force, what are those transverse force? The normal reaction to the tire, right? or whenever any weight transfer occurs. See here also, if any weight transfer occurs whenever you make the right or left corner, the weight transfer will occur. Weight transfer will occur in the opposite direction, right? The inertial loads or change in weight, or I can say the weight transfer. Here also I can say the weight transfer. Weight transfer. You got this thing? Sure? Sure? Or even in the longitudinal axis, those forces that are, yeah. And because of the case of weight transfer, you can see the normal rotation forces will change, so I can say it the weight transfer. While here, if I have to consider, I can say the inertial forces across my center of gravity location. If I have to say it, otherwise I would just go with these forces. You got this thing? Simple. So when I talk about the longitudinal axis, tractive forces are acting, acceleration, deceleration, whatever causes the acceleration and deceleration in the vehicle, the power produced, the torque produced by the engine is going to produce it. When I talk about the lateral axis, see this axis. The vehicle is heading towards you, this axis, lateral axis, I will call it the coordinating forces or the centripetal forces. When we talk about the transverse forces, these are the normal reactions, the change in weight or the static weight of the vehicle. Simple. Till here we got this thing? Okay. Now, the thing that I am going to discuss today is very fundamental, very fundamental. Most of the teams or most of the people I came across with in the last 4 or 5 years, what I found is students usually lack this basic. Right? They go with the hardened calculations that are available on internet rather than focusing on the very much fundamentals, or rather than just preparing the free body diagram of the vehicle. Right? So I won't be discussing the overturning movements that are going to acted on your vehicle, or the self-aligning torque or the aligning torque. Right? I won't be discussing all these things, but I am just going to discuss the very fundamental forces that are actually acting on the vehicle or that are acting on the wheel, right? Because these fundamental forces are so much enough to justify the complete characteristic of a vehicle, right? The behavior of the vehicle. Okay, now there are two things I told you, we will be discussing about the proper terminology. Like if you are dealing with a particular subject, you should be aware of the proper terminology, right? So now there is one thing, driver response to vehicle's reaction, right? Or I could say vehicle's response to driver's reaction, right, or behavior. A very good driver understands the vehicle reaction, right? If you practice very hard with the vehicle, you will know with my X response what is going to be the behavior of my vehicle, reaction of my vehicle, right? Why? A very good vehicle should have to support the driver in the extreme condition for the driver's reaction. Right? For the vehicle's reaction, again, the driver should have to be trained for the same. For the vehicle's reaction, suddenly a dip comes in your vehicle, gets down inside it. What is going to be the reaction of your driver? How is he going to behave with it now? Behave with the vehicle. You got this thing? These two terms, these two things should not have to be used interchangeably, but these are very much depending factors over which your complete dynamics of a race depends. Vehicle's response to driver's reaction and driver's response to vehicle reaction. On this thing only, your maneuver tracks are supposed to be built. Just on these particular terms, right? Vehicles react. When you go for a maneuver race now, the judge, the evaluator, or the track designer is only going to judge one thing. Only two things. What is the vehicle's response to the driver's reaction and what is the driver's response to the vehicle's reaction. That's it. You got this thing? So you have to put the very good alignment between these two factors. A driver is also a machinery, and driver should have to understand the machinery is going to be aligned together, assembled together, right? I told you, all the components that you are going to assemble in your vehicle have got a relationship between each other. So if a driver is also a part of the, is also a kind of component for the vehicle, it should have to have a relationship with the other sub-assemblies present inside the vehicle, right? Okay. Now you got this thing along the longitudinal tractive, along the lateral set coordinating, along the transverse non-rotation. I guess till now you must be thinking these are the very simple things you already know about this thing. Now just go down. Let's just get into the depth of this thing. So when we talk about the camber, or just consider this case. This case. Along the, let's talk about the movement. We have just talked about the forces now. Now we have just talked about the forces. Along the longitudinal tractive forces are occurring. Along the lateral coordinating forces are occurring. Along the transverse normal forces are occurring. Right? Let's go with the very basic. Now inside this we will be considering all the other factors. All the other factors you will be considering inside it. Right? Sorry. Okay. Change this direction here. Axis. Along these axes, these forces are acting. Right? Now let's go with the movement. Along longitudinal axis, which movement is occurring? Which movement is happening? Which movement is occurring in the vehicle? Longitudinal axis. This is the longitudinal, heading towards you, longitudinal axis. Which movement is occurring? Yes, which movement is occurring? Now you can see, if I talk about the movement, right? Like this is the axis, now this is the movement. Now this movement is the resultant of the perpendicular forces. Right? So now if I could say X, Y, Z. These are the three axes. Let's call X to be the lateral axis. Let's call Y to be the longitudinal axis. Let's call Z to be the transverse axis, right? Transverse axis. Now in this plane of lateral and longitudinal, which force is going to create the movement? Transverse force is going to create the movement. So in this plane of longitudinal and transverse, which force is going to create the movement? Lateral. Right? So now if any of the movement is occurring on a longitudinal axis, it could be the resultant of either the transverse axis or the lateral axis. If any of the movement is occurring along the lateral axis, it could be the resultant of longitudinal axis or the transverse axis. If any movement is occurring along the transverse axis, it could be the resultant of lateral axis or longitudinal axis. Now see this thing. Just see this thing. Along the longitudinal axis, which movement is occurring? Rolling. Along the longitudinal axis, which movement is occurring? It is rolling. Along the lateral axis, and let me write down these things in a smaller font so that I will be able to cover the other things also in the same. Sorry. Okay. Let me just refill it so it would be darker and you would be able to see these things better. Because today I used TikTok. It has got very amazing content. People are so expressive there. Okay, so see. If I talk about movements, I guess it's visible now. Right. If I talk about movements along the longitudinal axis, okay, let's write down like this: axis, action. Sorry. Here in the axis also let me write it down. Which axis? Movement axis, and the action that is happening, and the force axis. force axis, or I could say the arm axis. I told you now, like if it's visible, this is the x, y, z, lateral, longitudinal, transverse. Now, if a movement is occurring, if a movement is happening along the longitudinal axis, let's say longitudinal. Now we all know along the longitudinal which kind of action is happening actually. The rolling movement. The rolling movement is occurring, right? The rolling movement is occurring. Rolling movement. Dig, 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 dig of the vehicle. Rolling movement of the vehicle is happening. Rolling movement of the vehicle is happening. Now, along the lateral axis, which movement is occurring? Pitching movement is occurring, right? During braking or acceleration. Along the transverse axis, which movement is occurring? Along the transverse axis, which movement is occurring? The movement that is occurring on the transverse axis is the desirable steering input. Now let's just check. I just told you this rolling, if this rolling has been occurring, if this is the movement along this, right? This is the resultant of two forces. This rolling is the resultant of two forces. That is the lateral force and the transverse force, right? The lateral force, where is the lateral force? Yes, this is the lateral force. The lateral force and the transverse force. When I talk about the movement along the lateral axis, it's because of the longitudinal axis and the transverse axis. And when I talk about the movement along the transverse axis, it's about the lateral axis and the longitudinal axis, right? Okay. Now how these forces are acting? Now this is my vehicle. This vehicle is moving straight. This is my longitudinal axis. Right? Right, going across my center of gravity location. I can translate this axis from this position, anywhere in this plane, I can translate this axis. Got my point? Anywhere in this plane, I can translate my axis. Right? Parallel axis theorem. This is a mathematical formulation. Anywhere in this plane, I can translate my axis. Now, this is my longitudinal axis. Along the longitudinal axis, the tractive forces are acting, but these normal forces which are acting on the tire. Now see, everyone, see this thing. Longitudinal axis and the normal reaction forces, the normal forces are acting on the tire. Right? Now this is the axis. This axis is rotating. The normal forces acting over it won't create any difference. So there must be a trail. To create the movement, we need the arm. To create the movement, we need the movement or the torque. Movement, and the torque can only be produced if we have got the arm. And over the arm, the force is going to be acted upon. Right? So when I talk about the torque, how am I going to provide the torque? Like this. Right? So now this is the central axis. This distance, this diameter into the force that I have applied. The tangential force that I have applied is the torque. Right? Okay, now, so this is the axis, these are the reaction forces. And this provides the rolling. So whenever, like this is in the static position, this is like this. So whenever any change in weight occurs, any change in the normal reaction force occurs, what will happen? See, this is like this. So any reaction forces are there. This is the trail. Now along the trail I am applying the force, and this is moving. The normal reaction forces. Now guys, you got this thing. How is rolling happening? Normal reaction forces occurring because of the weight transfer. Right? Occurring because of the weight transfer. That is the transverse. That is that I'm just telling you the course of action, how it occurs, right? How these movements are produced. Now, longitudinal axis is the movement axis. We know how this transverse forces is acting. Now the trail that we have considered, see this is the change in weight, change in normal elevation. The trail that we have considered is half of the track width, or I could say the track width. The trail that I have considered is track width. Let me rub this thing down too. Okay. Force axis, right? This is the force axis. Force axis. Very good. And now this is the trail. Now force axis, when I talked about the normal force, right? When force axis is transverse. Along the transverse axis, oh, I just rubbed all these things, sorry yaar. Along the transverse we have got the normal. Along the lateral we have got the cornering. Along the, what is this? Transverse, lateral, longitudinal, we have got the tractor. Now it's visible, right? Everything is visible now. Now, which trail is this? Track width, right? Track width. Now you can find out the relationship between each and everything. Which track width? Front track width. Yes, front track width. Rolling in the vehicle, rolling in the vehicle. Now the other is lateral force. How the lateral force is going to create the effect? Now this is here the lateral force. So whenever you take a corner, these lateral forces will start to act. The cornering forces will start to act. Now these cornering forces will always try to tip you down, and this is because of the height of center of gravity. Height of center of gravity. Now tail is height of center of gravity. Center of gravity, height. Right? Center of gravity, height. Center of gravity, height. Now just see one thing, there is one more thing, like this is about the rolling, right? This is about the rolling. I told you I can shift this axis from the center of gravity location to anywhere in this plane, Let's take this axis towards the tire. Let's take this axis towards the tire and translate it in this different plane. Now when I talk about the plane, what are those planes? I have that also. So when we, okay, I can't write it here. Let's see here. X, Y, Z. This is the longitudinal, this is the lateral, and this is top down. This is transverse. Right? Now, in this longitudinal lateral plane, that is the ground surface top plane, and the longitudinal and the transverse axis plane. Right? This is the side plane. Right? Okay. Now when I take my longitudinal axis in the same plane only, that's why. When I take my longitudinal axis towards the tire, take it towards the tire. Now you can notice one more thing. Your tire, like the tractive forces are occurring. Okay, what actually I want to discuss? Okay, let's discuss it later. Let's move with the lateral. Now lateral, along the lateral axis, the pitching movement is occurring, right? It could be because of the longitudinal and could be because of the transverse. Now, lateral axis, pitching movement is occurring. Whenever any weight transfer occurs, see the weight transfer occurs, this is the trail. Your wheelbase, half of the wheelbase is the trail and this is the reaction force. Half of the wheelbase is the trail and this is the reaction force. So I could say the trail is wheelbase. The trail is wheelbase for the transverse. Normal forces are the transverse, na? Wheelbase. Okay. And what about the longitudinal forces? Now this is my axis, and these are the forces that are acting, right? The longitudinal forces that are acting, the tractive forces that are occurring, or the inertial forces, or the D'Alembert forces, particularly you can say the D'Alembert forces. Either the D'Alembert forces are acting at the height of